Welcome to Aviation Maintenance Planning. This module is concerned with Part M Subpart C. We went through Part M. Hopefully now we've got an understanding of the different subparts. We understand that, for example, Subpart B is all about accountability. That Subpart B is also where we have an obligation to report to the regulator anything that we find. Now we're talking about Subpart C. Subpart C is the most important area of Part M concerning the maintenance planning department. It's got all the fundamental obligations which show compliance with ICAO. We spoke about the need to comply with ICAO Annex 8, and we will see that now in Part M Subpart C. Let's see what it says. First of all, it talks about continuing airworthiness tasks. So, when we talk about maintenance on the aircraft, some tasks have been identified as continuing airworthiness related. For example, the management of the airworthiness directives, the MODs, the life-limited components. All these elements are considered part of continuing airworthiness. Also, the modification status. Also, the repair status. Also, the weight and balance. Also, the certificate of release to service for all maintenance that the aircraft has received. The aircraft continuing airworthiness and the serviceability of both operational and emergency equipment. On board the aircraft we have a range of emergency equipment. Oxygen, fire extinguishers, etc., etc. And this emergency equipment has to be present, it has to be serviceable. And so it's the responsibility of the operator to ensure that the emergency equipment is serviceable before each and every flight. And typically when the cabin crew get on the aeroplane before the flight, this is what they're checking. They're checking the serviceability of the emergency equipment. In addition, we talk about the accomplishment of pre-flight inspection. What is a pre-flight inspection? Well, it's not a certifying inspection. A pre-flight inspection is an inspection of the integrity of the aircraft and the fact that the aircraft is good for its flight. But it's not a certifying inspection. Typically, flight crew carry out a pre-flight inspection. Other people can be trained to carry out a pre-flight inspection. What do we look at? It depends on the aircraft, but typically we're looking to see that all the panels are closed, that the engines are closed, that the aircraft configuration is correct, and that, for example, no safety equipment is left external to the airplane. I know, for example, of one airplane that took off in Nepal from Kathmandu. And it was a small airplane, but as the airplane took off, the pilot was unable to make the rudder pedals work. And the reason he couldn't make the rudder pedals work is because the lock, the external lock, the gust lock, had been left in. And as a result, he only had control of the ailerons and the elevators. And it wasn't enough to turn the aeroplane in the space that's available, because Kathmandu is a ring of mountains. The airport's at 4,000 feet, and the ring of mountains goes up to about 11,000 feet. And so he had no choice. He tried to put the aeroplane down, but he actually crashed, killed himself and killed the passengers. Why? Because he left the control lock in during the pre-flight. Not only that, he didn't check the control for freedom before starting the engines. So he failed with the primary check and he failed with the safety net. And as a result, he killed himself, destroyed the aeroplane and killed the passengers. So pre-flight inspections, whilst they are not a certifying check, they are are very important. Very important. And we need to identify what is required on the pre-flight check. Typically that will be in the aircraft maintenance program. In addition, the rectification in accordance with the approved data of any defects. And we have the obligation either to fix the defect, to defer it in accordance with the minimum equipment list, or to agree with the regulator a deviation that would allow us to return the aircraft to the base. So all defects should be documented within the process at all times. So aircraft cannot fly with open defects in the tech log. And as an example, if we have, for example, let me show you an aircraft flies from A to B, it flies from B to C, and it flies from C to D. It then turns around and it goes back to A. And each of these is a flight. So 1, 2, 3, 4, 5, 6 flights. And at the end of it, any defects have to be dealt with. But here's the point. If defects appear here and nowhere else, there is evidence that defects are being carried when they should be fixed. And it's very, very easy to see the evidence. Auditing, very easy to see and understand the evidence, because what happens if there is a defect during flight B to C, that should be fixed at C. And what happens, and sometimes it happens in the business aviation, they write the defects down on a piece of paper and they hand the defects to the engineer. And he says, I can't fix that. So, okay, well, we'll save it till the end of the day. This is not how to perform maintenance. And we spoke about the fundamental Part M process with the reliability, engineering, tech records, maintenance planning. We can see what's happening without a great deal of trouble. And if we carry defects that are not being dealt with correctly, then we leave ourselves exposed. Again, I will share stories with you that are in the public domain. Turkish Airlines, 3 years ago. They had an airplane, it was going into Amsterdam. The airplane was at 2,000 feet. There was a defect on the radio altimeter that was not written in the logbook. The defect caused the airplane to think it had landed, and the throttles retarded automatically. And the captain, not sure what was going on, pushed the throttles forward. And the airplane said, no, retarded again. And so they're fighting with the automatics. Meanwhile, the airplane is losing speed. And the speed of the airplane deteriorated to the point where the airplane was becoming unflyable. And so what happened then, they disconnected the auto throttle, they pushed the throttles forward, the engine is trying to spool up, and it takes time. And the airplane was at about 500 feet, and the captain pulled the control column back to raise the angle of attack. And of course, as you raise the angle of attack, the speed reduces. So the speed reduced even more. In fact, even though he was at 500 feet, his only chance was to push the control column forward and head to the ground and get some speed up. He didn't. And it's very easy for me as a maintenance guy to make these comments, because with hindsight we're all very aware. But again, it's back to training, competency, knowledge, understanding. Any pilot that practices that in the simulator will never happen to them ever. However, when he pulled the control column back, the airplane speed reduced even more, and the airplane fell out of the sky and landed, crash landed, broke open the airplane, killed the pilots and several passengers. Part of that problem was not recording equipment failures. And again, the quality system of the organisation, the regulator can very easily see when an aircraft flying multi-sectors, if there's defects on the last sector, it speaks volumes. The organisation is kidding itself.